Okay, it's 12:29 Central Time, 10:29 Pacific Time. I'm going to probably just get started with a few of the discussion items before we get going with our presentation today. Um, my name is Don Tiemann. I'm the Vice President of Sales and Operations for ASP Enterprises, Quick Supply Company, Bowman Construction Supply, and Cascade Geosynthetics. We called a little audible today. Our engineer, Mr. Bill Murphy, was under the weather today, so I am the host of your webinar today. So if the webinar looks a little rusty, it's been a while since I've done a webinar. I think we'll all be good though. You know, a quick introduction of the companies. These companies, they're family companies. This is a family run business. It's gotten to be a decent size, but it's still very family oriented. Many of these companies have been 40 plus years into business, a whole ton of customers, obviously. One of the big ones is 27 plus sales professionals. I also like to call them technical sales representatives, providing specification assistance, project support, both in design as well as installation, and really being the boots on the ground to make sure that products are installed right. 5 CPESCs on staff, that's Certified Professional Erosion and Sediment Control. So it just gives you an idea that they're technically knowledgeable, both in this case in erosion control, but also in stormwater management, geotextiles, et cetera. And then, like I said, Bill Murphy is our civil engineer. He's, again, unavailable today. So when you look at the coverage for all those offices, it's 9 offices covering 12 states. You can see there. And this webinar is focused on the quick supply, Bowman and Cascade markets specifically for the Cultec product line. In terms of site solutions and the products that we represent, erosion sediment control has been something we've done for years and years, as the geosynthetic solutions. Definitely been a mainstay of all our companies for a long period of time. Stormwater management over the last 10, 15 years has gotten to be more prominent, and we've gotten much more involved in that aspect, as well as in some of our branches do the hardscape line. So that's pavers, retaining walls, and all that kind of fun stuff that you can put either in your backyard or wherever, and really can enhance things. Then some secondary markets, I say because it might be only with one company, like Bowman Construction Supply has a bridge division that does expansion joints and bearing pads, also has a big waterproofing division. So that's drainage as well as membranes, et cetera. So really have quite the wide range of site solutions to help you solve any of your project problems, take care of any issues at all. Probably one of our big values is, besides that technical support we supply, we also have a significant inventory in those 9 warehouses. I actually looked this morning, and today we're just under $13 million in inventory in those 9 locations. So we have significant products sitting on the ground to support your projects and make sure that we can take care of anything that's going on that you might specify. And those products also are some of the premier manufacturers in the country. So TinCut and Mirify, Profile Products, North American Green, Presto Geosystems, Fleximat, all those that you see there, Tensar, those manufacturers also supply great technical support. So that's where that support comes from manufacturer support, as well as our technical sales representatives, our engineer, and then our comprehensive websites. That each company has their own website, so you can see the links there. And one thing I wanted to mention is also the YouTube channel that this webinar will also be posted to. But if you look over here, you can click on that little arrow button. That is our YouTube link that can send you straight to YouTube and our channel that has all those videos and product presentations. Also, we're pretty strong on LinkedIn, so if you connect with any of these companies on LinkedIn, then you'll see some of the projects we're working on as well. So with that, we will then go to Cameron Brown, and I'm going to move my slide here so we can get his information out here. So then you can see the contact information, and you will have this on follow-up stuff and emails too, so you don't have to worry about writing that down today. But those websites can be very valuable in terms of product documentation, installation guides, all that kind of stuff. So with that, we will get to our speaker today, and that is Cameron Brown. Cameron was born and raised in the mountains of Southern California, where he learned to love the outdoors and construction. Currently living in Utah with his wife and 3 daughters, Cameron is engaged in the construction markets locally and across several other states. Cameron is a licensed engineer and has experience in consulting, construction management, owners representatives, and manufacturing sales. Cameron grew up appreciating a mean storm, which probably fed his appetite to focus on stormwater design and solutions. Cameron began working with Cultec recently because the company's solutions are a great match for Cameron's promotion and sustainable design. And I will tell you that Cameron's one of the reasons that we picked up Cultec, because we really believe both in Cultec, but in Cameron's approach to things. So with that, I introduce you, Cameron Brown.
Good afternoon or morning, depending on where everybody is today, and hope we're in the middle of a good week. I'm really excited to be teamed up with Don and his team with this webinar today, and to present to you a little bit about Cultec and some of the solutions that we offer. Let's see here. There we go. As Don mentioned, my name is Cameron Brown. I have a professional engineering licensure because I stepped into this industry believing that I was going to be a consulting engineer for quite some time. I imagined myself, having a whole career and retiring in it, but recessions and changes in attitudes kind of changed some of that, and I'm really happy to be working with Cultec as their Northwest Technical Sales Manager. As far as the company Cultec, perhaps you've heard of Cultec. Most likely, the farther east you are, the more likely you are to have heard of Cultec. But just by way of introducing the company, Cultec was the first innovator of an arched plastic chamber. The DiTullio family was running precast operations in the New England area and innovated the plastic chamber to serve a better function with septic applications. And shortly after bringing that product to market for the septic applications, the phone started ringing from civil engineers inquiring about using the product for stormwater purposes. And from there, the stormwater solution innovation from Cultec took flight, and we're a very proud manufacturer. We strictly manufacture chambers, and we really believe that less is more. That there's a lot of ideas out there about what a complete chamber system requires, and we'll go into that a little bit more later here, but suffice it to say that throughout this presentation, you'll probably find a moment to appreciate that mantra, that less is more. So that innovation took place back in 1986. And so for nearly 35-ish years here, we're going on. The company's continued to innovate. And here are a few just kind of hallmarks. It started out with the small chamber there, the Contactor 125. And over these years, we've added several more septic chambers, but more importantly to this discussion, numerous stormwater chamber models ranging from 8 inches in height all the way to 48 inches in height, and 8 different sizes within that range. So we believe we offer a very comprehensive size solution for just about any setting. And the company still continues to innovate and pursue verifications and so forth. As we know, continuous improvement is definitely a thing these days, and Cultec is totally familiar with that attitude. So just briefly, for those who may not understand, why are we using chambers, and what is this all about in the first place? So these products are intended for the purposes of keeping stormwater on site where the rain fell, so that we don't have downstream issues with flooding, with erosion, and there's a variety of hydrologic outcomes that arise when a site is developed, or in other words, when it is changed from, a field or, even a dirt patch into a paved parking lot with, a structure and a roof. And now all the water is essentially shedding from the site rather than soaking in at the site. And what these products do is provide an opportunity to capture that water, to store it on site, to let it infiltrate, and or to meter the water out from the site in a controlled rate that is within flood control parameters. Historically, this objective has been accomplished by building a surface detention pond. And we still see a lot of those these days. But the closer you get to a heavily urbanized area, you'll find that real estate values are very high. And so when developer A wants to build build an office suite, he doesn't want to build an office suite with a parking lot and then have another half-acre pond that he has to purchase land for. Therefore, what the chambers offer is an underground solution where the use of the space can be dual purpose. It could be parking lot and storage, or landscape and storage. And so these are all underground products that are traffic rated and capable of supporting earth loads and all that kind of stuff. And we refer to that as a detention system, an underground stormwater detention system. Breaking it down into a little bit more of a technicality, there's detention, and then there's retention. And retention, the best way to think about it is that you're retaining the volume. So the R's line up there, you have retention and retaining. And with retention, you're wanting to keep those stormwater volumes on site, let them infiltrate into the ground and or evaporate and or be reused for irrigation purposes. Whereas detention is a solution to just scalp off the peak flow and discharge a managed flow rate into the storm drain system. You could have a lined detention system in which all the water is eventually let downstream, or you could have an unlined detention system, I should say, which will still promote infiltration, but that's not the primary purpose. Both of those, detention and retention, are what I would call the volumetric application of stormwater. So that's that little V that popped up there. Taking it a step further, what are these products used for? The Q stands for quality. Now, the quality, stormwater quality is achieved by various methods with these systems, but just touching on it, it's the ability for the water to settle, for the sediment to settle out and to be retained within one of the chamber rows, where it can be evacuated by a vacuum truck and appropriately disposed. We could also throw in there that you get some incidental BMP storage with these types of units. If they're dispersed around single family houses or street side LID types of applications, you're going to get the storage out of it, you're going to get the treatment out of it. And so there's kind of a secondary application that these units serve, and that is the water quality aspect. Primarily, though, this is a volume focused solution. We talked about detention versus retention. On the left-hand side there, what you see is a cross-section of our chambers being used adjacent to a street and a sidewalk. This is actually a cross-section that was developed by New York City, and what they are trying to accomplish in an environment that's probably at least 99% impervious is to put as much stormwater in the ground as possible for a variety of reasons. It's volume, it's stormwater management, it's reduction of demand on pipe flow facilities, it's putting fresh water in the ground versus salt water. So there's a lot of reasons why they're using it. But as I understand it, the city has targeted, hundreds of thousands of feet of street alignment where they want to install an application just like this, and we have served some of those functions. So I put that slide on there because it actually shows an application of each of the 4 of those purposes on the right hand side of the slide. So the key elements of a chamber installation or a chamber design are depicted on this slide. The picture on the left is a nice, just kind of isometric layout. It's computer generated, it's hypothetical, and then on the right hand side is basically a cross section. And so what you'll see, I'll just kind of start top left and go. Well, actually, I'm going to start the bottom right, where it's called out native soil, because then I can kind of work clockwise from there. But to install these systems, you're going to excavate a trench down to a set elevation, and it's just going to be surrounded by native soil. Obviously, we're putting it in the ground in place, and then after that trench is excavated, we're going to wrap that trench with a non-woven geotextile. So typically like a 4.5 ounce non-woven geotextile, and it's wrapped all the way around the trench for the purpose of keeping the fines in the native soil from migrating into the void aspects of the stone bedding. So that's the first fabric application. The second fabric application is this woven geotextile, which is placed directly underneath the chambers of the separator row, which we'll touch on that a little bit here in a second. Typically, that's really only under the separator row. Right above the outside fabric, we place this foundational stone, and that's a minimum depth of stone from the bottom of the trench to the bottom of the chamber. Typically, that's something like 6 inches or 9 inches, depending on the project and the design and even the chamber model. I've seen that foundation stone up to 3 feet. I've seen it added to just for some added capacity. I've seen it increased for structural bearing considerations. Typically you're going to see 6 inches or 9 inches of that foundation stone. Once that foundation stone is placed and leveled, the chambers are placed in rows like you see in the picture on the left. And when the chambers are done being placed, we commence with the backfilling of what we call the embedment stone. So all the stone that you see in this cross section is typically approximately 1 inch angular crushed stone. It's not road base. We don't want road base. We want stone because it provides the additional storage capacity for stormwater, and it also provides the optimal structural capacity for the envelope around this chamber. So that's the embedment stone all the way up to a specified height above the top of the chamber. Typically, again, that's 6 inches or 12 inches and can be increased as needed. Once that embedment stone is placed to the specified height over the top of the chamber, that non-woven fabric is again wrapped over the top so that it's a continuous perimeter around the chamber envelope. Above that layer of non-woven fabric is the compacted fill material. And so typically that's going to be, something like road base compacted to 95% of Proctor max, and then pavement above that. And by the way, that's a minimum. We can go these minimum heights from the top of chamber to top of embedment stone. There's a specified minimum. And then for the rest of the backfill, there's a specified minimum as well as a maximum. Most of our chambers go up to 12 feet of total burial depth over the top of chamber. And so we have quite a range of depth that these can be installed in. On the left-hand side of this slide, you see the several rows of chambers. And you'll notice that on the farthest left row, there's a row of chambers that looks like it has, fabric draped over it. Well, that is fabric that's draped over it. And as well as fabric being draped over it, there's also fabric run underneath it. As I mentioned, that is the woven geotextile that goes underneath the separator row. The separator row is the primary inlet into this system. So all of your low flows and the majority of even your intermediate and higher flows are going to go into this row and have the opportunity to have that settling out. And the reason for that fabric right below the chamber is so that as sediment accumulates, trash and debris or whatever, future users of the site have a nice surface to work on to clean that sediment out. And typically that's accomplished with a jet nozzle, just like you would clean a sewer pipe. That material gets jetted back to the manhole that's upstream here that you see in the picture, where it could be evacuated with a vacuum truck. We put the fabric over the top of the chamber as well to help prevent the sediment and debris from leaking out into the rest of the system. And I'll just say that most of the time, that level of concern probably isn't necessary, but it's really cheap insurance to put that fabric on there and just make sure that whatever sediment ends up in this row is not leaching out and potentially clogging the rest of the system. For a few $100s, you can have that assurance and be able to maintain whatever sediment accumulates in that row, versus, you could say, let's not include that fabric, and you end up with a rare site that has a really high sediment problem, and your bed loses its functionality after 5 or 10 years because it got occluded with sand and fines. So there's a lot of items in the design here that I would call like cheap insurance, and they're really intended to provide the assurance that the system fulfills its design life as intended. So thinking of those installation features and so forth, they all work with all 8 of our chamber sizes here. So as I mentioned, 8 chamber sizes ranging from 8 inches to 48 inches in height. And there's a lot of versatility with the product line when we have this many sizes, because as you know, sometimes you're designing sites that have shallow groundwater, shallow outlet, bedrock, whatever might be the case. And, you might not want to jump all the way from an 18-inch chamber all the way to a 30-inch chamber. Maybe a 26-inch chamber in the middle of that is great, or a 20-inch chamber. So we have across the top row there, you can see the heights of the different chamber models that we offer. They're really nominally like 8 inches, 12 inches, 18 inches. The reason you see 8.5, 12.5, 18.5 is because we have our inspection port knockouts on the top of the chamber. That's where you would connect an inspection port if needed. And those do bump up a little bit, but everybody refers to these as, an 18-inch chamber, 20-inch chamber. You can kind of neglect the 1/2 inch. So maybe a question that comes up, at least it does in a lot of presentations that I give, is, why would we use chambers? Why couldn't we just use, perforated pipe or some of these concrete modular systems, or, there's a variety of different products out there. And frankly, I think they all kind of have their place. The reason chambers are available in the marketplace is because they've proven their versatility and their economics. In this picture, you see a fairly, sizable field of chambers, only partly built. And it's storing a great amount of water. I have no idea what project this is or where it is or its actual statistics, but I can tell that it's our largest chamber, our 902 HD. It looks to be near 18 or 20 rows wide, and they're just getting started going from one end to the other. So in my mind, I'm thinking that there's probably near an acre foot of water going into this system. And most of that water is going to be managed by the chambers. So if you were to consider some other products, why were chambers selected? Well, first of all, let's just look at the capacity and the economics of that capacity. With that much water, what are your other options? If you went with a perforated pipe, you would need, several hundred to potentially a couple thousand feet of perforated pipe, depending on the diameter that you're using. And then assuming it would be larger diameter for a large system such as this, you'd be talking about, multiple truckloads of product being delivered and staged on site. Whereas you look at these chambers, and as you see in the bottom right corner of this photo, you have 15 chambers stacked on one pallet, and you get 10, 12 pallets or 15 pallets, depending on the size of the truck, on one truck. So this whole job that you see right here delivers on probably one and a half or two trucks worth of freight, versus if this were going to be pipeline, it would be 15 or 20 truckloads. The handling of the product, each of these units can be picked up and carried by two people. You start talking about pipe of almost any diameter, and you're talking about using heavy equipment to sling it and hoist it and drive it across the site and plug bells into spigots, all that kind of stuff. So there's some handling stuff there. The constructability of chambers is considered to be very simple and straightforward and economic. A four-man crew can install about 40-ish of these chambers per hour. And so you can imagine they can install a pretty large bed in one day. Hitting on the space efficiency again, like when these deliver to the job site on a truck, they fit in the corner of the development, out of the way. They're not occupying an acre of space. The freight efficiency on the truck is a great way to point out, kind of some sustainability mindset. There's just a variety of advantages that come with the sizing, the space considerations that these chambers offer. The arch shape, open bottom, wide at the bottom, arching up to the crown, you just get a lot of stormwater volume in these units, and so you just get typically an overall lower cost. Even when all the stone and installation, everything is considered, chambers are typically the most economical option. And finally, since they've been around since 1986, in both septic and stormwater applications, it's pretty easy to say that they've proven themselves in a wide array of applications and intensities. We have installations underneath highways and in airport settings. We have them in truck loading docks for Amazons and Costco's and all these kinds of places where, before even being installed, they were heavily vetted and have continued to prove themselves as a viable structural solution, as well as a stormwater package that is economical to the developer. On a site-by-site basis, you're going to have some considerations. So the engineers in here will probably be most interested in this slide right here, but starting with your site-specific hydrology, are you looking at a 1-hour storm? Are you looking at a 24-hour storm? Find where the critical stormwater volume, what type of storm and event it comes from. And with that, I will say that there are areas in the country where you are allowed by code to subtract the soil infiltration rates from your rainfall rates. So after you total the sum of your rainfall, you can subtract out the infiltration rate through the footprint of your design system and get a kind of an incremental reduction in the size of your system. That's not typical most places, but there are areas where that is allowed. And I frankly, I encourage it because it's based on actual science. If you're using a geotechnical report and you have some site specific parameters suggesting that your infiltration rate is worth considering. Once you know your volumes, you got to find a place to put it. Again, most urbanized areas are not interested in making a surface pond. So now you're limited to areas outside of the foundation of the building and between right-of-way boundaries, maybe some other considerations, some landscaping. Maybe there's some big trees that are being preserved or added to the site later. Maybe there's some light pole structures. We can work around all of those with our units because you can start and stop a row at about any point. But once you know how much you need, it's pretty typical just to assume a rectangle length, width, and then depth or height that's available based on, your vertical constraints. And then what are your cover limitations? And depending on if you're in a traffic area or if you're in a landscape area, there are different considerations there. And so we have guidance suggesting what those cover limitations ought to be for either setting. It's actually a little bit more cover for the landscape settings because in the traffic settings, you're usually getting that compacted road base along with some sort of asphalt or concrete to disperse loads. Total cost has to be a consideration. Hopefully it always is a consideration in our design efforts. I know we move really quickly through these processes in order to get permitted, but at some point before materials are purchased and installed, there has to be kind of an evaluation of the economics. And that's one area where, Cultec can really shine because we can take a look at options and make recommendations on, different chamber sizes, and maybe what looked like an obvious 330 chamber model solution actually should be a 360 chamber model solution, and it'll save some space and save some dollars, etc. But even before you get to Cultec, maybe you have, maybe you considered something else that was also competitive in the cost arena. So as you develop budgets for your projects and know what your construction budgets are, that's an important consideration in stormwater like it is for the rest of the site. So what does Cultec offer to engineers specifically, or anybody else who's trying to figure out some solutions? We really have, I think, a pretty good website. I think it's resourceful. I think things are relatively easy to find, but I always welcome the feedback that, hey, this really seems like it's in the wrong place, or this wasn't as helpful, or I just straight up couldn't find something I was looking for. And we make adjustments. We've made some adjustments here in the last 2 weeks based on some input that we got back. So I think we have a great website. You can typically find resources for design guidance, for installation guidance, information about each chamber model, how it's configured with the bedding and the minimum bedding and soil cover and just spacing and all those kinds of layout considerations. We have contractor resources like the installation guides. We have a link that I could probably send out later, but it's called our quick reference page, and it's a clickable PDF, and it's basically just has it organized in a format that is pretty easy to follow, and every piece of literature that we offer is on that PDF somewhere, organized either under by chamber model or by engineering resources or contractor resources, whatever. And it's clickable, so you can just hit it and it'll take you right to the document in PDF form online. From there you can download it, store it, whatever. Cultec also has in-house engineers that work full-time developing submittal packages for, initial plan inclusion, or just looking at concepts with engineers to, get a design hammered out, as well as assembling submittal packages during, the final approval phases and so forth. We have a site calculator. If you've used anybody else's site calculator, ours is pretty similar. It's just a variety of parameters that are entered in, and spits out some answers and some solutions, and you can keep iterating until you find what you believe to be an optimal solution.
Hey, Cameron, if you send Madeline Drury, our marketing specialist, those links, we can put those out in our follow-up email.
Noted. I'd be happy to do that. Thank you.
Mm-hmm.
So really what I just wanted to kind of hit on here, this is kind of one of my last standard slides, is the difference that Cultec brings to both the design and the construction phases of the projects. Really is a company that wants to be a partner. We don't want to be a bulldog. We don't want to tell you how to do your job. We don't want to tell you how a design has to be. We make a product. And we let engineers and designers fit those products into their plans as they see fit. For example, if you look at the middle picture on the top row here, the integral, or excuse me, the picture to the left, the internal manifold. We offer this internal manifold. We don't require it. A lot of engineers understand that these systems are just like a bathtub, and it fills up with water and then it drains. And there may not be a need for some internal manifold connections. Some other engineers do believe that, hey, you know what, if I'm going to have an underground utility, I want access, to every part of it in case I ever need it. Like, I may not ever need it, but if I do, I don't want to have to dig it up, right? And so it really just depends on the level of comfort that you have, or the application that you see taking shape, that Cultec isn't going to come tell you, hey, you have to use our internal manifold. If you're confident that the installation will go well and there's not going to be problems, which a lot of engineers are, then the internal manifold often gets neglected, and that's fine. Cultec's not going to void a warranty or whatever for that reason. Same with the inspection ports. I've seen some projects where they had inspection ports on every single row. And why did you do that? Well, manufacturer recommended. Well, why? Like, why do you inspect the separator row? Why do you need inspection ports on every row? And sometimes there's a great reason, and so it's there if you need it. We offer these solutions. We want to give you the solutions so that you can design a complete system as you see it needing to be completed. From the standpoint of service, we offer the in-house engineering services. We'll work with you and your team to put drawings together and design a system all the way to completion. I mean, we'll take that task completely off your desk. If anybody needs some time, let us know. We're here to help. Rolling it over into the construction phase, all the representatives at Cultec are dedicated to getting out into the installation scene with these contractors, being there to answer questions, point out what some of the different parts and features are and how they work, how to put them together, to verify that the stone on site is the appropriate stone. And there's always a question that comes up, and I never feel bad about that. I frankly, if they would ask all the questions, I would feel really great, because I know that they're paying attention and they're concerned. Other contractors have done it 1,000 times, and they know what they're doing, and I'm okay with that as well. But I want to make sure that at least I've been on site and said, what questions do you have? And if they say no questions, I'm going to just kind of make sure, like, okay, so how the fabric goes and what fabric goes where. It's kind of funny because sometimes you'll catch them off guard and they aren't quite sure. They thought they were sure, but then we want to make sure that the whole installation, the whole solution, the whole project is a success. And so we do that by being present, being physically present on the job sites, going over stuff and asking questions of them, and making sure that they have a great appreciation for how it goes together. We're about at 50 minutes. Where are we at, Don?
Yeah, it's 10 after, so we got about 10 more minutes.
Okay. Here's just, maybe screenshot this if you want, but this is just kind of a flow chart of how, Cultec can get involved and help you with your design processes as you're getting them approved with your local authorities and so forth, as well as, what we do to be on site when the project is being installed. And so it's just a nice, we can jump in at any time. I'm helping engineers right now who don't even know where they're going to put their system, and we're trying to figure out, well, where's a good place? They're up on a hillside and they don't want to induce, landslide hazards. And okay, well, maybe we do it with a line. So we just, we put our heads together, and I'm a big fan of putting our heads together and making sure that the considerations are well vetted. And we can really be a part of your process, whether you're in a concept phase or even a final phase. And frankly, as it turns out, I frequently get involved with this, even as like a post-bid value engineering phase. And occasionally, we totally shift directions and go a totally different way than what was originally anticipated. So whatever the case may be, we're wanting to make ourselves available for that. I think that's a big part of what I do. From a standpoint of wanting to be a solution provider, I bring the experience to support that, having been a designer myself, and then also now getting more focused on just this type of application. It's really opened some doors for me to be helpful with these processes. There's a lot of other slides here that might actually just be better for questions that come up or whatever. So Don, if that's all right, you can initiate that. And before you jump in, I just want to invite any question that is out there. Don't be shy. I'd love to see what I can do to clear your mind of anything that seems fuzzy.
Yeah, the first question we have is, where is the product made and how is it shipped?
So the product is made in 2 locations in the United States. We have manufacturing in Wisconsin and in Ohio. Typically, we're shipping these truckload at a time wherever they're going. And I always get the question, well, isn't the freight, add a ton of price? Well, the answer is, yeah, we pay for freight in the process, but certainly every other manufacturer is paying for freight as well. So it's not really a disadvantage. A lot of the products that we sell are made in the same places as some of our competitors. So they're all coming kind of from the same place. And then when you compare it to alternative products like perforated pipe or some of these concrete modular units, yeah, they have to be made from somewhere and shipped from point A to point B. But the nice thing is we get so many of these units on a truck that even shipping from the Midwest to just about anywhere in North America is pretty inconsequential to overall project budget.
Well, I guess, dude, this day and age, people are talking about carbon footprints, and that makes a difference. Besides just the cost of it, the carbon footprint is less because you have less trucks. Very
true. Yeah. Again, going back, there's actually a project going on out here in Salt Lake right now, where it's not a stormwater project, but it's actually a prison project. And the prison cells are being made out of precast concrete sections, and every single one of those things, they just weigh so much that you can only put one on a truck. And I don't know how many cells there are, but
oh my goodness.
Basically the state is relocating their state prison, and so I imagine there's several hundred of these things, and you could compare it to a stormwater vault, right? I don't think you could put more than 2 larger concrete vault systems on a truck. And when you have to put, 80 or 100 of them together, that's 40 or 50 trucks versus you could probably accomplish that with 1 or 2 truckloads of chambers.
Very good. Very good. Does Cultec require manhole structures as a part of a complete system?
So the answer to that is generally no. Cultec is not going to require a manhole upstream or downstream of any system. The only consideration really has to be, you know, what is the access to the system, particularly to that separator row. You have to be able to get to that separator row. You have to be able to draw the pollutants to a local manhole somewhere. So while we don't require one, there does necessarily need to be one within a reasonable range that that separator row can be maintained. Other manufacturers, you know, they have one drawn on the upstream and on the downstream, and to prove what their function is, you know, takes, you just have to scratch your head because no one really knows what they're for. What do they do?
Yeah.
So.
You know, you talk about this separator row. I know in some of these systems I've seen, there's actually a manhole that may do some water quality benefits ahead of it. It sounds like Cultec, it doesn't see a need for that. That this separator row will do the same thing. Is that typically approved by a lot of the agencies as a water quality device?
So there are some agencies, yes, that will approve a separator row as a water quality device, at least with the the performance of it. That said, I'm a big fan of what I would call, you know, a treatment train. And if you have the opportunity to put something upstream of a system like this that could separate out some of the sediment and the trash and the whatever pollutants, you know, I think that's an advantage to be realized. So, you know, do you need a really fancy hydrodynamic separator upstream of one of these? Probably not. But would it be worthwhile to take your nearest manhole, add a couple feet of sump to it, and use like a snout structure to try to keep you know, the bulk of the sediment and pollution out of the sediment row? I believe so, yes. And then in the case of the chamber array being an infiltration system, that upstream manhole is literally, you know, preventing some of the the heavy metals and certain things from getting into the ground, provided that it's being maintained regularly.
I guess in some cases it might be a little bit simpler to clean those out, and so it might be more cost effective even if you're spending a little bit more.
Absolutely, yeah. So the key there was the cost effectiveness of it. It's a lot easier for a single manhole with a vertical drop to the bottom to be vacuumed out and cleaned out with a vac truck than it is to deploy the jet nozzle and to bring all that sediment back. Certainly possible, just a little more time consuming and complex of an activity. So, I don't want to go too far out on a limb in my next statement here, but what I tend to see is that most chamber systems end up being on a site that is fully paved and or landscaped. So what opportunity is there really to generate a lot of sediment? Enough that, cleaning these things out even has to be regular at all. Most of these systems, in my opinion, they might get cleaned out one time in their entire service life because 3 inches of sediment finally accumulated. But in the terms of, the long-term need to maintain these frequently, it's just not a reality. And as I said, I don't want to go too far out on the branch here because I have heard of some of these systems filling up with sediment, but the reason was obvious. They were at the bottom of a watershed where phase development was upstream. Their erosion control was poor, and guess what? It rained really hard last night, and now your separator row is full of sand.
Yeah.
So, got to go fix it.
Very good. It looks like the last question we have is, can your systems be stacked?
So yes, our systems can be stacked, and we don't widely promote that. just for the simple reason that every stack system is going to require like a kind of an internal review, if you will. We want to take a look at some of the soil parameters. We want to take a look at, what is the total vertical arrangement going to look like, and just to make sure that loads are going to be distributed and that stormwater volumes are going to be satisfied in an acceptable way. We look at each one separately just because we probably couldn't have like just standard guidance for a double stack system. So yes, they can and have been double stacked in a lot of real world settings and done very well. And we continue to offer that as a solution where needed.
Okay. And then when you're doing that, is that the next layer would be perpendicular to the previous layer?
Actually, yes. Good question. So you're going to be rotating the layer above about 90 degrees to just distribute that load,
right,
in a more uniform pattern.
Okay, very good, very good. Excellent presentation, Cameron. I don't see any other questions. Again, if others have questions, you can certainly put it on your survey that Madeline's going to send out a link to here, probably even yet this afternoon. Again, we've given you quite a few websites to work from. Cameron's going to get us some links, and that'll be a part of Madeline's email as well to get you some immediate information as you move forward. The limited exposure that I've had with Cameron and his company is they're very good on this preliminary design and even working with existing projects as an alternative. So those are all great options, and this Cultec company really just seems to be the real deal. So we're excited to be working with Cultec and excited working with Cameron. If we don't have any other questions, we're going to be able to get off here a few minutes early today. Again, just a reminder, you'll get an email from Madeline Drury that has your link to the SurveyMonkey. You cannot get a PDH certificate without completing that SurveyMonkey survey. Madeline, probably the first of next week, because we want to give people enough the rest of this week to get those completed. She will then go in, pull all those surveys, create the PDHs, and you will see that email in response. Again, you've got email access or emails of any of us that if you have any questions, we can certainly respond as well. And we thank everybody for their time, and we thank Cameron for participating today. So thank you, everybody, and have a great day.